Hello and welcome to my video, lesson 3.1 on trigonometric ratios. We shorten it to trig ratios normally. So the basic concept here is SOHCAHTOA. The way to remember this, I do this in class for those of you who have me. Okay, so I pour the water on my feet right in front of you. It's fantastic. Anywho, SOHCAHTOA is an acronym that we use to help us remember what the trig ratios are. So here are the three trig ratios. I'm just going to write them out. Sine of the angle equals opposite over hypotenuse. Okay, that's the first part of the trig ratio. The second part is the CA, which is cos of the angle equals adjacent over hypotenuse. And the third one is TOA, which is tan of the angle equals opposite over adjacent. All right. So hopefully, if you look at these diagrams and look at the equations, you can kind of see what this means. If the angle is here, the opposite side is the one that's furthest away from the angle. The hypotenuse is always the one that is on the longest side, and it is opposite of the 90. The adjacent is another word for next to. So if I say I'm sitting adjacent to someone, I'm sitting next to the person. And if you flip the side, the side that the angle is looking from, it also flips the opposite and adjacent. So from this perspective, and the second triangle, right, now this one is opposite and this one is adjacent. But the hypotenuse is always the longest side. Okay, make sure you're in degree mode with your calculator. In my calculator, let me first reset it so that you guys can see what that would look like. I'm just going to reset my calculator. It's going to reset for you. When you reset a calculator, you'll notice up here in the top right it says radian. This is going to be true for a TI-83, TI-84, or TI-80 plus CE. It says radian whenever you clear a calculator. That's usually the case. Now, how to change it? You click this mode button. Then you go down where it says radian and it says degree. You go to the right by one, so you're highlighting degree. You press enter. Now degree is highlighted. Now it will show degrees. So now I'm going to press clear. Now I'm in degree mode. Now it says degree up here. So now I'm good to go. Okay, so make sure you're in degree mode with your calculator. Every calculator is going to be different other than the TI-83, TI-84. Those sets will follow the same instructions I just showed. So, in degree mode, what do? We label the triangle first. We decide which trig function to use, fill in the equation, rearrange using opposite operators, opposite bedmass, then solve in your calculator. So, let's try these three questions right here. I'm going to scroll down just a tiny bit. There you go. And we're going to start by maybe with let's use blue. Okay, we're going to label our triangle. Okay, so based off of the position of the angle and the fact that this is the longest side, this is our hypotenuse. The close one is the adjacent side. The further one is the opposite side. And we can do this for all of the different triangles, okay? So we will in a moment, but let's just stick with this. The second thing is to decide which trig function we're looking for. So before we can do that, actually, we need to know what are we looking for? This is side AB. So we're looking for side AB, which is at the bottom here. Okay, this is what we're looking for, which means that we do not care about one side. We don't care about the opposite. Since we don't care about the opposite side, we're going to cross out the trig ratios that use the opposite side. We're going to use the cos trig ratio. So cos of theta equals adjacent over hypotenuse. Okay, this is pretty much going to look the same for all of them. Now let's fill in the equation. So this is going to be cos of 30, that's our angle, and I'll maybe leave that in brackets, okay? And then equals adjacent, which is our unknown, so I'm just going to leave it adjacent like this, over hypotenuse, which is 5. Okay, then what we have to do is use rearranging using opposite operators, opposite bedmass. So to solve for unknown, our goal is to get our unknown on top and then by itself. So in this case, we're looking to get the unknown, which is the adjacent side, on top and by itself. It's already on top, so we just need to get it by itself. So what we do is we do opposite operators. Opposite of dividing by 5 is to multiply by 5. So that's what we're going to do here. So that means these ones will cancel. We're going to be left with the adjacent side over here. Okay? And we're going to be left with this lovely equation. Okay, now that we have that, now we just have to plug it in our calculator. So 5 cos 30 end bracket. Whoops, that's not end bracket. There you go, end bracket. Press enter, and we should get an answer. Okay, so let's just choose a different color here. Let's pick orange, and this was, what was it, 4 point something? 4.33. I'm just going to do it to the nearest tenth of a degree, of a centimeter or whatever. Doesn't say centimeters, but that's what it would be. Okay, let's try the next one out here. Same sort of steps, labeling the triangle first. This is the hypotenuse. This is the opposite side. This is the adjacent side. Now we're looking for side AC. So now that now that we've labeled it, and we're looking for this side, that means we don't care about the adjacent one, which means instead we're going to cross out these two, and we're going to be left with sine of the angle equals opposite over hypotenuse. Now we're going to fill in the equation, so we're going to go sine of 45 equals opposite, which is unknown, so I'm just going to leave it as op, or opposite, over hypotenuse. And actually, this is not really what I wanted. I'm going to flip this around a little bit. I'm going to flip this around by doing a very quick little swap, which is to put the 7 over here, and we're going to look for side BC opposite. So instead, we're looking for side BC. And the idea here is that I want to show all three types of equations. So this is going to look a little different. So this time we're going to have the top, and we're looking for the bottom, the hypotenuse. So we need to get the unknown on top and by itself. So first of all, the unknown's on the bottom, so we need to move it across the equal sign to get it on top. So when we rewrite this out, we get h times sine 45 equals 7. Then we can divide by sine 45 on both sides. And this will leave us with h equals 7 over sine 45, which equals 7 over sine 45, which equals 9.9. Yeah, we're going to leave it there. 9.9, which is our last step, which is plugging it into the calculator. Okay, one more triangle to show you guys. So the first one we solved for the top of the ratio, the second one we solved for the bottom of the ratio. The third one here, we're going to solve for an angle. Notice here it says angle ABC. So if you draw from A to B to C, it creates an angle. It's this angle in here. That's actually what we're looking for. So we're looking for this angle. Okay? So we're going to call it angle theta. And from that perspective, this is the adjacent, this is the opposite, and this is the hypotenuse sides. Since this is what we have, okay, we do not care about the hypotenuse, so we're going to write the formula out now with tan theta equals 4/3. Okay, now what we're going to do is solve the equation. No, we're going to fill it in, sorry. Yeah, normally we do that differently. Hold on. I'm just going to write it out the same as before so that we don't get confused. Sorry about that. Instead of doing 4/3, I'm just going to write opposite over adjacent, just to keep it the same. Anyways, so now that we do 4/3, now we're going to do opposite operators in order to move the tan over. So here's the deal with opposite operators. Tan and tan -1 are opposites. Cos and cos -1 are opposites. And sine -1 are opposites. So to move one of those over is to take the sine -1 or whatever. So let's show this example. Whoops, that's not really what I want. So we use second function tan, which gives us the tan -1. And then a fraction, 4/3. Whoops. We'll put the bracket out here, which gets me 53.1 degrees, which I wanted to use the other color for. 53.1 degrees. All right. So that is one example of each. One solving for an angle, one solving for the top of the ratio, one solving for the bottom of the ratio. I highly recommend that you now use the same skills, and pause the video maybe right here, use the same skills and do the next 3 triangles. Okay, pause it, try it out. Okay, now we are going to take a look and solve them. Okay, so you're going to compare your answers to mine. So, first things first, we need to label all the triangles or figure out what we're looking for. In this case, I wrote angle C, but I labeled this wrong. BCA. Did I do that on purpose? Okay, could have gone either way. Maybe pause the video now. Okay, so let's take a look now. So we've got, if we're looking for BCA, that's angle C over here, which means this is the hypotenuse, this is the opposite side, and this is the adjacent side. Now, which one do we not care about? Well, we don't care about the adjacent, which means that we're going to use SO, which is sine of the angle equals opposite over hypotenuse. Okay, now what we can do is we can rewrite it out with the values inside. Now what we can do is use opposite operators to solve for the equation here, to solve for the unknown. So now we're left with theta equals sine -1 of 15/17, which when we type it into our calculator, whoops, that's not a helpful button, there you go. When we type it into our calculator, we get 61.9. So 61.9 degrees. All right, for this next one, we're solving for side BC, which is over here. So this is the hypotenuse side, we have the adjacent side, and this means we do not care about the opposite side. So if we don't care about the opposite side, we're going to use cos theta equals adjacent over hypotenuse. Then we're going to write cos 25 equals adjacent over hypotenuse, which is our unknown. So I'm going to just put x, or you can put h, doesn't matter. Now we're going to get our unknown on top by multiplying by it on both sides. Those cancel there. We're left with x times cos 25 equals 9. Now we're going to divide by cos 25 on both sides. So now we're left with x equals 9 over cos 25, and we get some sort of value. So let's try this out. 9 over cos 25, enter. So we get 9.9. Is that the same as what we had in the previous example? Huh, interesting. Huh, just interesting that that works out. So I guess those are related triangles. Oh, I guess not necessarily, but probably. Okay, anyways, let's try the next one here. So this is the angle, so that means that this is the adjacent side, this is the hypotenuse side, and this is the opposite side. Since we're looking for side AC, this is what we're looking for. We don't care about the opposite side. So we're going to use cos again. Okay, so cos of the angle equals adjacent over hypotenuse. So cos of 35 equals adjacent over 12. Okay, unfortunately, this is flipped in a way that is easier. So if you did it this way, you would have gotten a nice simple answer like this. But I'm going to make another version right now, just so you guys can see what a more complicated version would look like. So this is, wow, all my numbers are very similar. So 9.8, so hopefully you got that. Okay, but let's just make a different version right now, where instead we're going to go like this. And we're going to say that we have the 3 there. Okay, so if we have that 3 there and we're still looking for the same side as before, right, then that means we don't care about the hypotenuse. We're still looking for the adjacent side. So it would be tan of the angle excuse me, equals opposite over adjacent. Okay, and the thing that makes this more difficult is simply, it's not too bad, it's simply that's one step further, because when we write down all of our numbers, we're going to notice that the unknown is on the bottom. Right, so we can multiply that across, and we get x times tan 35 equals 3. Then we can divide by tan 35, tan 35, whoops, not like that. Those cancel, we're left with x equals 3 over tan 35, and we get the answer of 4.2. 3. So the key here is that every question will be different. Sometimes we do it on top, sometimes we do it on the bottom, and sometimes we're looking for the angle. So please, if you just follow these steps using opposite operators, opposite bedmass, trying to get the unknown on top and by itself, then all of these questions end up being the same. All you have to do is memorize so katoa, and everything else works. Hope this video helps, and good luck.